Now, if you notice here, so I'm going to put the numbers here that this is 9, this is 16, and this is 25. If you notice, right, that 3 belongs to 9, 4 belongs to 16, and 5 belongs to 25. And how did I get that? Well, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And so I know that the small squares, if you add the small squares, it equals the big square, right? 9 plus 16 is 25. So I know here that 9, plus 16 is 25. And so if I use the side lengths, this is the same. Let me zoom in a bit. This would be the same thing as saying 3 squared plus 4 squared is equal to 5 squared. And so this diagram on the left introduces what the Pythagorean theorem is. The Pythagorean theorem states that the two smaller sides, if we square them and add them together, it's the same as the square of the big side. And the way you see it written is a squared plus b squared is equal to c squared. That is the Pythagorean theorem. This is the equation that we are going to be using through this whole lesson. Another thing that you will probably need is you will probably need your calculator. I'm sure most of you have your phone right next to you anyway. So we could use that to figure out the answer to a lot of these problems. Okay. So let's see if we can apply what we just kind of visualized here to another diagram. So here, they give me 2 of my side lengths, but they do not give me what C is. But I do know that one of my side lengths is 10, and my other is 15. Okay. So if I know that this is 10, I know that the area of this square is just 10 times 10, and that would be 100. 15 squared is 15 times 15. And if you do that on the calculator, that gives you 225. So this is 225. But remember, what did we do up here? So I'll come back to this if you were copying it down. So remember here, we added the 2 small squares to get the big square. So if I add 100 and 225, I will already know that C squared is 325, right? Because 100 plus 225 is 325. And so how do I go backwards? How do I go from 100 to 10 and 225 to 15? Well, you take the square root of both sides. And so if I take the square root of 325, you're going to use your calculator. You're going to get a decimal, and it's going to be around 18. Okay, it's not exactly 18, but it's close enough that we could say it's 18. Now, the formula here. So now I'm going to show you how to do this without using a diagram, because this is how the homework is going to be. A squared plus b squared is equal to c squared. We're going to use this formula over and over again today. So here, A is 10, because that's just the length of one of your sides. B is 15. And C, we don't know. That's what we're trying to find. So if I square this, this is 100, and this is 225. So you see how I get the same thing here, right? That's where the 100 and 225 come from. And then if I add the 100 and the 225, I get 325. So you see that's where this comes from. So 325 is C squared. And if you remember, how do I get rid of the square? The opposite of squaring something is to square root something. And then once again, if you use your calculator, you'll get this is approximately 18. Okay. So that's that. Give me a second. I am actually going to skip number 2 because there's a lot of diagrams and this is a pretty long sheet. I just want to do one more with the diagram, and then I want to show you how to do the problems that are going to be on your homework, okay? Which are more just straight into the equation. So actually, let me see. Okay, I'm going to do this one down here. The one that's 25 and 169. So this time, they give me the area of the square for B is 25, and they give you the area of the square for C is 169. So we're trying to find A here. We're trying to find all of the sides, but remember, to go from here to here, you just square root. The square root of 25 is 5. And the square root of 169 is 13. So remember, how do I get this here? Well, remember, if I add the two smaller squares, I get the bigger square. So now I'm just going to subtract. 169 minus 25 is 144. And then if I take the square root of that, I get 12. But let me show you how to do this using the formula. A squared plus B squared is equal to C squared. So this time I'm looking for A. And then B squared is the square of B. So this is 25. And C squared is the square of C. So this is 169. So you see, I'm just going to subtract 25 from both sides. And then I get A squared is equal to 144. And then take the square root of both sides. And so A is equal to 12, which is what I have on the left side. Okay, so those are examples using a diagram with the square, but a lot of the times when you see problems with Pythagorean theorem, they're not going to make it like this with this triangle and these squares coming out of it. You're just going to see a triangle. So I'm going to skip the rest of the diagram problems because it's really more just to get an intuitive feel to it. But now I'm going to go straight to the formula and things you need to know. Before we move on, one of the things that you might wonder about is, how do I know which one's A, B, and C? Okay. A and B are the legs of the triangle. And C is always going to be the hypotenuse. So if you're kind of rusty on what the legs and the hypotenuse are, the hypotenuse is always across the 90-degree angle. Okay? So when you see a right triangle, find your 90-degree angle. The 90-degree angle will always be indicated by this square here. And the side that's across from it will always be your hypotenuse. The hypotenuse always has to be C. Okay? And then A and B are going to be your legs. And now here's the question. Does it matter which leg is A and which leg is B? No, it doesn't matter. Okay? I can make this A and I can make this B. It doesn't really matter when you do Pythagorean theorem. The only thing that matters is C has to be the hypotenuse. If you do not make the hypotenuse C, then you are getting these questions wrong. Okay, so now let's go ahead and try to do these problems by using Pythagorean theorem. Now, let me just point out one more thing. You can only use Pythagorean theorem in right triangles. So if the triangle has a 90-degree angle, you can use Pythagorean theorem. If it does not have a 90-degree angle, you cannot use Pythagorean theorem. However, all of the questions mostly today will have right triangles. So look at number one. You do not have the squares coming out of it, but you should know how to do this problem. So I know it's a right triangle and you're missing a side, and they give you two of the other sides. So this is simply going to be, I'm going to use the Pythagorean theorem here. Remember that this is your 90-degree angle, so the side across from it, that's your hypotenuse. And so it doesn't really matter if the x is A or the x is B, if 12 is A, 12 is B. As long as 13 is C, you'll get this question right. Okay? So if I do x squared plus 12 squared is equal to 13 squared. So you see, that's all I did. Oh, sorry, I forgot the 2 squared here. I just plugged in my numbers to where they belong. 13 is the hypotenuse, so it's C. I plugged in x for A, 12 for B. If you plug in x for B and 12 for A, you would still get this question correct. So now I just do the math. 12 is 144. 13 squared is 13 times 13. That's 169. I subtract 144 from both sides because now I'm just solving for x, right? And so x squared is equal to 25. I square root both sides. And the square root of 25. Now, we've taught you before that you have to put plus or minus when you take the square root in an equation. However, since this is triangles, you can never have a negative length. So we only choose the positive one. So x is equal to 5. Okay, does anyone have any questions on how that was set up? How it was solved? Okay. So number 2, once again, I am going to use Pythagorean theorem because it's a right triangle. They give me 2 sides and I'm missing a third. So this would be 3 squared plus 4 squared is equal to x squared. So you see this time, your hypotenuse is x. So that's why x is c this time. So now this is going to be 9, this is 16, and this is x squared. This time you don't have to move anything to the other side because x squared is already by itself on the right side. 9 plus 16 is just 25. And then once again, I'm going to square root both sides. And so x is equal to 5 here as well. So you see how 1 and 2 were slightly different? For number 1, they gave you the hypotenuse. They were looking for one of the legs. For number 2, they gave you both of the legs. They were looking for the hypotenuse. And that's why the C is what we were trying to find for number 2. But for number 1, we were trying to find the A. Now for number 3, just because you have decimals doesn't mean it's anything different. You're just going to be using your calculator more for this question, right? So for number 3, if I do a squared and once again, when you do your homework, you don't have to be writing a squared plus b squared equals c squared every single time. You could just go straight into the plugging in step, but just make sure you are plugging in. Remember, across the 90-degree angle is your hypotenuse. It doesn't really matter which of the other two you make your a and which one you make your b. So this would be x squared plus 11.9 squared is equal to 14.7 squared. And this is where you would just take out your calculator and figure out what 11.9 squared is and what 14.7 squared is. So 11.9 times 11.9. You're just going to use your calculator for this. You get 141.61. And then 14.7 squared is 216 and 9 cents. Oh, that's not money. 216.09. I just use the calculator. Now I'm going to solve for x. So we need to subtract 141 from both sides. Once again, you could just use your calculator here. If you subtract that, you get 74.48. And then once again, you're just going to square root both sides. And if I take the square root of 74.48, you get around 8.6. Remember, those of you that have iPhones, all you have to do is just press 74.48 and then press the square root button. I think you do have to turn it sideways. If you have an Android, I think you press square root first and then do 74.48. So it's different depending on what type of phone you have, right? iPhones, you just need to press 74.48 and then press square root. Androids, you press square root 74.48 and then press equals to 8.6. Does anyone have any questions on how that was set up? Because I'm going to skip 4 because it's the same thing. I'm not going to do every single problem here because it gets repetitive. Okay. Now, number 5, number 6 is the same thing as 1 through 4. You're finding a missing side, but look at the directions. Leave your answers in simplest radical form. This is different than round your answers to the nearest 10th. So here, we're not going to be plugging it into the calculator. We need to leave it in radical form. And if you forgot how to do that, we're going to review it right now. So number 5, once again, I'm doing a squared plus b squared equals c squared. Once again, how do I figure out which one's a, which one's b, which one's c? As long as the one that's across the 90 degrees is your hypotenuse, so this is c. So I'm going to do x squared plus 13 squared is equal to 15 squared. Now I just do the math here. 13 squared is 169. 15 squared is 225. And then so now we just need to get everything on one side. Whoops, sorry, this should have been a plus. There we go. So now I'm just going to subtract 169 from both sides. You're solving a normal equation. And I get x squared is equal to 225 minus 169 is 56. Okay, now how do I solve for x? Remember, you just have to take the square root of both sides. So this time, when you see the directions, as in leave it in simplest radical form, what you need to do is you need to simplify the square root of 56. And if you remember from class, we did this many times. You could just go ahead and do the factor tree. So 56 is 7 times 8. 8 is 2 times 4. And 4 is 2 times 2, right? We don't have to worry about that anymore. And so if you forgot how to do this, remember you are going to circle things that come up in pairs. Anything that does not circle gets put back on the inside of the radical. So the 2 comes out because it was circled, and the 7 and another 2 don't get circled, so I multiply those 2 and they go on the inside. So here, my final answer here is 2 square root 14. Once again, the 2 here, this 2, comes because I circled the 2 here. And then the 14 comes because I didn't circle the 2 and the 7. So I multiply them and that stays on the inside. Okay, hopefully you all remember how to do that. So let's do it one more time with number 6, just to make sure you got this. Once again, you are using the same exact formula that we have been using. Remember, the C is what's always across the 90-degree angle. It doesn't matter which one you make your A and which one you make your B. So I have 8 squared plus B squared is equal to 16 squared. And so this is 64 plus B squared. Or you can make it X squared. I forgot to make it X squared. That's the same thing. And then 16 times 16 is 256. So now I'm just going to subtract 64 from both sides. And 256 minus 64 is 192. The button for the square root on the iPhone, Rodney, should just be, I think it's the one that looks like this. If you have something like that, because I don't think you have this. If you have, can you check which one it's supposed to be? It's one of these two, but I just don't know which one it is. Can anyone else verify? Okay, yeah. And to try it out, Rodney, just go ahead and go back to this problem and do 74.48 and press that button. And if you get 8.6, then that's the correct button. So let's go ahead and figure out what the square root of 192 is. So remember, we need to square root both sides. Oops. And then so if I do a factor tree for 192, 192, if you just play around in your calculator, you'll see that you could divide 192 by 4. You could have also divided by 2 because it ends in a 2. Okay. So I know 4 is 2 and 2. 48 is going to be 4 and 12. 4 is 2 and 2. 12 is 4 and 3. And then the 4 again is 2 and 2, right? So I circle 3 pairs of 2. So remember, if you circle more than one, I have to multiply all of these circles together. 2 times 2 times 2 is 8. And what I did not circle, which is the 3, goes on the inside. So in simple radical form, it's 8 radical 3. So remember, we're not adding the 2's to be on the outside. We're multiplying them. 2 times 2 times 2 is 8, right? You have 3 pairs of 2. So 2 times 2 times 2 is 8. And then the only number that I did not circle that's at the end of a branch is 3. And so that goes on the inside, 8 root 3. Any questions there? Okay. Number 7. Now look at number 7. Find the missing side of each right triangle. It's the same thing that we've been doing. The only thing is they do not give you a picture, but they actually tell you what A and C are. So this should be fairly simple too. But we're going to do this one so that we could just keep reviewing the radical form. So if once again, if your answers are leave in your answers in simplest radical form, you have to do the factor tree. So I have 11 squared plus b squared is equal to 15 squared. This is 121. 15 squared is 225. I subtract 121 from both sides. And then so I get b squared is equal to 104. Once again, if you play around with your calculator, you'll see that 104 can be divided by 4. So I get 4 and 26. 4 is 2 and 2. 26 is 2 and 13. I could only circle these pairs of 2's. And then everything that I do not circle goes on the inside. So B, and I multiply them when they go on the inside. This is 2 radical 26. Because 2 times 13 is 26. Now, number 8. Okay, so this one's a little bit different because one of them has a radical here, but I want to show you how to do this one. It's the same, it's basically the same thing, right? So I have a squared plus b squared is equal to c squared. And so now I'm looking for a. They tell me that b is root 6. And they tell me that c is 4. Okay, If you remember from class, I told you that the square root and the square will cancel each other out. So if I have root 6 squared, that's just going to turn into the number 6. So I have a squared plus 6 is equal to 16. Subtract 6 from both sides, and I get a squared is equal to 10. Then I just square root both sides. And if I try to do the factor tree for 10, I only get 2 and 5. Nothing circles, so it's already simplified. A is equal to radical 10. Okay, so before we move on for the last couple of problems, I want you to make sure that when you do the homework, you do this correctly. So if the directions say round your answers to the nearest tenth if necessary, when you take the square root, you could just put it into the calculator to get your answer here. However, if it says leave your answers in simplest radical form, you need to go ahead and do the factor tree to figure out what the answer is. Okay. Last couple of questions. State if each triangle is a right triangle. Now, if a triangle is a right triangle, then Pythagorean theorem has to work. If Pythagorean theorem does not work, it is not a right triangle. Like, Waldo, you need to see the problem, or you need to, oh, okay. Okay, give me a second, guys, and then we'll move on in a bit. Okay, so let's move on to the last type of question you'll get on your assignment. State if the triangle is a right triangle, and remember, the idea is if Pythagorean theorem works, it's a right triangle. If it doesn't work, it's not a right triangle. And I don't want you to see this and say these are all right triangles because they all look like right triangles. They just made it look like right triangles when not all of these are going to be a right triangle. So the way we're going to do this is the same way we've been doing all of our problems. You start with a squared plus b squared is equal to c squared. And then, so remember, the hypotenuse is always the largest side. So this is going to be 9 squared plus 12 squared is equal to 15 squared. And you're just going to check if this is correct. So I get 81 plus 144 is equal to 225. You just go in your calculator and you just have to see what 81 plus 144 is. And if you check, it's actually 225. So this statement is true. And so this is a right triangle. Okay. Now, number 10, once again, I'm going to do the Pythagorean theorem. This is the one that probably confuses a lot of people because of the 2 root 39. So I'm going to put 10 squared here, 2 root 39 squared is equal to 16 squared. Now, the thing that's confusing is what is 2 root 39 squared? Now, remember, I told all of you just from number 8 here, a square and a square root cancel each other out. So see how square root of 6 squared just became 6? Same thing is going to happen here. I have square root of 39 and I have the squared here. But what's really happening is there's a parentheses around all of this. So we are just not squaring the 39. The root 39, we are also squaring the 2. So you see what happens here is 2 squared is 4, and root 39 squared is 39. So it's 4 times 39. Does everyone see where that comes from? 2 squared is 4, and root 39 squared, the square root and the square cancel, so you're left with 39. So this whole thing becomes 4 times 39. Okay. So this becomes 100, and then 4 times 39 is 156, and then 16 squared is 256. And so now you just ask yourself, is 100 plus 156 256? Yes. So this is going to be a right triangle. Okay. Now I'm going to do one problem where it's not a right triangle so you can see. Okay. So for number 11, once again, we're doing a squared plus b squared is equal to c squared. So once again, the hypotenuse is the 11. So this will be 9 squared plus the square root of 115 squared is equal to 11 squared. So now let's go ahead and just do the math here. 9 squared is 81. The square root of 115 squared, this one's easy because remember the square root and the square cancel each other out. So this is 115. And then 11 squared is 121. Now, if you look at that 81 plus 115, you already know it's not going to equal 121, right? Because 81 plus 115 is too big of a number. Okay. So 81 plus 115 is 196. Yeah, I'm going to post the video, Paulita. So 196 is not equal to 121. And then, so this is not a right triangle. Okay. Okay, so number 12, I'm actually going to skip because you do the same thing, right? You're just going to do a squared plus b squared equals c squared. And then you're just going to check. So I'm not going to do this problem because, but you just need to check, is this statement true or not? Just go ahead and work it out on your calculator. If this is true, it would be a right triangle. If it's not true, it's not a right triangle, right? So, and the reason why I'm not doing 12 is because I'm doing a very similar problem for 13. Okay. So the last question is okay. So here I'm going to do a squared plus b squared is equal to c squared. So I'm going to do 10 squared plus 49.5 squared is equal to 50.5 squared. Okay. So this is 100. 49.5 squared is 2,450.25. And then 50.5 squared is 2,550.25. And now if I just see this, if I add the left side, this works. So this is a right triangle. Okay, so